Welcome to class PM. The previous class we have studied like how the human ear can hear the sound, and we have also learned that the eardrum which is present will help in hearing the sound, and we understood that our ear should not be damaged so that we'll be left with hearing impaired, right? So this class let us learn about amplitude and the frequency of vibrations. Amplitude and the frequency of the vibrations. So, if you remember, in the beginning of the lesson, we have learned that these vibrations are nothing but to and fro movements. To and fro movements. The to and fro movement is said to be oscillation. So, this kind of motion can also be called as oscillatory motion. What is this oscillatory motion? See, vibrations are nothing but, vibrations means to and fro motion of an object. To and fro motion of an object is said to be vibration. So when you talk about this to and fro motion of an object, this to and fro motion is also known as oscillatory motion. What is it called? Oscillatory motion. If you remember, regarding this oscillatory motion, using a simple pendulum. So the vibrations, as per the definition in the text or from the lesson, what we have learnt is the to and fro motion of an object is said to be vibrations. At the same time, from the previous knowledge which we have acquired from the chapter motion and time in class 6, we know that this to and fro motion is also known as oscillatory motion. So the number of oscillations per 1 second is said to be the frequency of oscillation. What is frequency of oscillation? That is nothing but the number of oscillations per second. So now when you are talking about this oscillatory motion, when you talk about the frequency of oscillation, that is nothing but the number of oscillations per second. When you take the simple pendulum, if you remember, we have hanged a small bob tied to a string, and we just vibrated it, and as it keeps moving to and fro, the time taken to complete one oscillation, right? So let us count the number of oscillations in the given time. So this number of oscillations per second is known as frequency of oscillation. Unlike all other quantities have units of measurement, the same way frequency also has a unit of measurement, which was actually coined by a scientist called Hertz, right? So it is named after him as Hertz. Okay, it is denoted by Hz. Hertz. Okay, capital H and small z. So as there are units for various quantities, in the same way frequency also has a unit which is named after the scientist who has invented this, called as unit Hertz. So how do you denote Hertz? As Hz. So a frequency of 1 Hertz, when you talk about frequency of 1 Hertz, it is nothing but 1 oscillation per second. So when you talk about the frequency of 1 Hertz, that is equal to 1 oscillation per 1 second. Say like, if I say like 20 Hertz, then it will be 20 oscillations per second or given time, right? So this is nothing but the frequency of 1 Hertz. Now, so many a times we know that without seeing the object, we can identify the sound, right? There are many a times which happens, like without seeing the object, you can identify the sound. Now, how come that you are able to identify the sound of an object without seeing it, right? This is the sound of object is recognized by without seeing it through 2 factors, that is amplitude and frequency. So this amplitude and frequency which are present, they help us to recognize the sound. That is what I told you. Many a time, see, if early in the morning during spring seasons, you see the koel humming or singing, right? So you know that it is koel. But how do you know? From the sound of the koel, you recognize that it is koel without seeing it. And sometimes we see the hummingbirds hum, right? And we immediately recognize, even though we don't see that it is a hummingbird. And sometimes you know that when your father shouts in the dining hall and you're in the bedroom, you immediately recognize that it is your father who is shouting at you, right? So that means sometimes you don't see the object, but still you can recognize the sound of an object. That is possible only because of 2 factors called amplitude and frequency. Now let us learn about these 2 important properties of sound. So as I've told you, these are the two factors or the properties of the sound which will help us to understand about the sound, right? Amplitude and frequency. As I've told you, I gave you numerous examples, like without seeing the object you can still identify the sound, right? So that is only because of the amplitude and the frequency. Now let us see what is amplitude. Amplitude is defined as, amplitude is what? The maximum extent of a vibration, or you can say oscillation, measured from the position of the equilibrium, See, if you remember, I told you that the sound travels in the form of wave. So let me show it in the form of wave only. Let me draw a sound wave, right? Say like, let me draw a sound wave and show you the amplitude. So when you try to plot a sound wave, this is how the sound wave appears, right? So this is said to be the amplitude. This is nothing but your amplitude. So this forms your amplitude. So the maximum extent the vibration reaches, right? So the maximum extent the vibration is measured is said to be the amplitude of the sound wave. You see, this is the apex part, and you see that from apex the maximum extent the wave has traveled. The amplitude varies in different sounds. We'll learn about it. So this is what amplitude is. And you know, frequency is nothing but the oscillations per second, right? So this will help you to better understand that even though the object is not seen in front of you, you can easily identify who is that speaking, or what is the sound coming out of that place, right? And to better make it a clear understanding, let us do a small activity. Take a glass, okay, and take a spoon, and what you do is hit the brim of the glass with the spoon. Immediately you can hear a sound. Now what you do, this will help us to understand the frequency of the sound. So when you hit it gently, the sound produced will be very less, right? And when you hit it or strike it very hard, the sound produced is very louder, right? In the same way, when you just walk out of the room, okay, walk out of your bedroom, when you smoothly close the door, right, swiftly close the door, you can hear a smooth sound. And when you bang the door like this and go away, then definitely you will hear a very huge sound or a large sound which is produced, right? That is said to be the loudness of the sound. Now you might have understood what is loudness, right? See, if I speak very slowly, that you will not be able to hear. So like, it is very smooth voice, right? If I speak in a very smooth voice, then you say that the loudness of the voice is low. But when I start speaking, right, like when I start saying that I can speak louder in a loud voice, right, you can hear it properly, right? So that is the loudness of the sound. So that you can just do this experiment and actually understand the loudness. That is, when you hit it or strike it smoothly or gently, you can hear a gentle sound. And when you strike it harder, you hear a very hard sound which is produced by the brim of the glass tumbler. So if the amplitude of the sound becomes twice, then the loudness will become 4 times. That means it will increase 4 times. And you know what is this loudness expressed in? Yes, the loudness of the sound is expressed in decibels. dB, decibels, which is also indicated by dB. So loudness is indicated by a unit called decibel, which is indicated by dB. So the loudness of the voice, when the amplitude is twice, the loudness increases 4 times. So normal breathing rate is 10 decibels. When you whisper, soft whisper is 30 decibels, and a normal conversation is 60 decibels, right? And you can say busy traffic can be 80 decibels. So that is in signal areas and traffic jam areas, it is 80 decibels. Your ear cannot bear the sound beyond 80 decibels. So now you can compare the sounds of a small baby, a grown-up child, yours, your parents and your grandparents. So there is a difference in everyone's voice, right? Definitely. See, when a small child speaks, the voice is different. And when an adult speaks, the voice will definitely be different. And when an old parent or a old grandparent speaks, there is a difference in the voice, right? So this frequency which is present, it will help us to determine the pitch of the sound. That is called as pitch. What is it called? Pitch. Okay, the frequency which is present will help us to determine the pitch of the sound or shrillness of the sound. So when the pitch is high, you can hear a louder, right? You can hear it louder, the vibrations. Say like if the frequency is high, then definitely the pitch will be high, right? And if the frequency of sound vibrations is low, the pitch will be low. Let me write for high pitch and low pitch. Let me draw and show you the amplitude. This is in case of high pitch. That means the vibration frequency is very high. You can see the level of amplitude. You can see the extent of amplitude of the waves, right? And in case of low pitch, it's flat. So can you see this, the extent of amplitude? See, this is amplitude, right? And this is also the amplitude, right? So you can see the difference of the amplitude in both the cases. This amplitude in case of this of low pitch is too low, but whereas in case of the high pitch it is high. That's the reason the frequency of the vibration is high, then it is said to be high pitch, and if the frequency of the vibration is low, then it is said to be the low pitch. So that is the reason when you are standing for assembly, when you have assembled for the assembly in the morning, and you know that you will be given a drum beat, and if the person who is giving the drum beat will hit it gently, the frequency produced will be less, then that will be a low pitch, and if he bangs it, then whole school which has assembled for assembly can hear it, right? So that is how you can actually differentiate between a high pitch and a low pitch. See, on the other hand, you see that whistle has a different frequency and a roaring lion has a different pitch, right? And when generally the shrillness of the women's is more than the men. That means women shout a lot. That is universal fact, right? You people may think that women keep shouting a lot, but it isn't true. The voice, the pitch in case of women is little high, whereas compared to the male. In case of males, the shrillness is deep, but whereas in case of female, the shrillness is like higher, So you hear different sounds of different objects, and you can actually understand whether it is a high pitch or a low pitch.